This is the first review we're doing for the Unit 3 test. This was the in-class review we did on Friday, November 30th. So the first 8 questions is asking us to classify the triangles by their sides and by their angles. Okay. If we remember, we have 3 classifications for sides. Okay, we have scalene, isosceles, and equilateral. Scalene triangles are triangles that have the sides have 3 different lengths, so each side has a different length. Isosceles triangles have 2 sides that have the same length, and equilateral are triangles where all the sides are the same length. And then we can classify by their angles. Okay, so we can have right triangles. We can have acute triangles. We can have obtuse triangles. And we can have equiangular triangles. Okay, equiangular triangles are triangles where all the angles are the same. So those angle measures are going to be 60, 60, and 60. So that means they're also going to be acute triangles, because acute triangles are triangles whose each angle measure is less than 90. So all 3 angles are less than 90. Obtuse, you're going to have one that's more than 90. And then right, you're going to have one that is 90 degrees. So if we look at number 1, all right, we notice we have 2 sides that are congruent. So if we start by classifying by sides, isosceles is where we have 2 sides congruent. So number 1, we have an isosceles triangle. We also notice we have a right angle. So if we have a right angle, it makes it a right triangle, right? The definition of a right triangle is a triangle with a right angle. So this is a right triangle. So it's an isosceles right triangle. Okay. Number 2, again, we notice we have 2 pairs, or we have 2 congruent sides. So it's going to be isosceles. If we look at our angles, we notice we have 2 acute angles and 1 obtuse angle, right? So if this was 90, this was a right angle, right? It would look something like that. Okay, but as you can see, the angle we have is bigger than 90 degrees. Since it's larger than 90 degrees, it is an acute angle. Okay. So here's our right angle. Okay. Since it's larger than 90, it's going to be obtuse. So this is our obtuse angle. Okay, and we only need 1 obtuse angle to make it an obtuse triangle. So this is an isosceles obtuse triangle. Okay. Number 3, we can see we have 3 sides that are congruent. So this is going to be equilateral. If it's equilateral, we know it's going to be equiangular. And those angles are all going to be 60, 60, and 60. Okay, again, equilateral. So lateral means sides. So if you're moving laterally, you're moving side to side. So equal sides. And then equiangular, obviously equal angles. Okay, the next one, I don't like this problem, but I think the implication was that each of the sides were different sizes, or different lengths. So each side is a different length. It's going to be scalene. Scalene triangles are triangles that where all the sides have a different length. And then all of our angles here are acute. So we have scalene acute triangle. Number 5, here we have, they're giving us the angle measures and the side length. So we notice we have 2 side lengths that are 3.8 and one that is 5.8. So since we know 2 of them are 3.8, we know it's going to be isosceles because 2 sides are the same length. And we look at our angle measures are 40, 40, and 100. So we notice that one of those angles, 100, is greater than 90 degrees. Since we have one angle that's greater than 90 degrees, right? We have one obtuse angle. And if we have one obtuse angle, we have an obtuse triangle. So this is an isosceles obtuse triangle. Right, next one, 2.9, 2.4, 2.9. So we have two sides that are the length 2.9. So again, we have isosceles. And again, we notice 65 degrees is less than 90, so that's acute. 50 degrees is less than 90, so that's acute. And 65 is less than 90, so that's acute. So we have three acute angles, which means we have an acute triangle. So we have an isosceles acute triangle. Okay. Number 7, the length of the sides are 6.2, 9.8, and 10.3. So all of those numbers are different. All those lengths are different. Since all three lengths are different, it's going to be scalene. (77 degrees, 67 degrees, and 36 degrees are all less than 90. So this is going to be an acute triangle. So it's a scalene acute triangle. Number 8, we have side lengths 3.3, 2.3, and 2.3. Since two of those lengths are the same, 2.3 and 2.3, we have isosceles. We have angle measures of 45 degrees, and 90 degrees. Okay, since we have a 90-degree angle, we have a right angle, we have a right triangle. The definition of a right triangle is a triangle with a right angle. So this is an isosceles right triangle. Nine, 10, 11, and 12. They're asking us to find x. So we have a bunch of different options we can use. We can use the Triangle Sum Theorem. We can use the exterior angle theorem. We can use linear pairs, potentially vertical angles. So there's all sorts of different theorems that we can use here. We just got to figure out which one is appropriate for each problem. So number 9, we notice we have a right angle, so that's 90 degrees. We can use the Triangle Sum Theorem, which says that the measures of the three angles of the triangle are going to add up to 180. So we know 90 degrees plus 49 degrees plus x plus 44 is going to equal 180. So 90 plus 49 plus x plus 44 equals 180. We combine like terms. We have 90, 49, and 44. That's going to give us 183. Plus x is 180. Subtract 183. X is going to be -3. Okay, and remember, the angle measure can't be negative. The x value can be negative. Okay, so don't let that stop you. Don't let that confuse you. Okay, if we substitute in the -3, we get -3 plus 44, which is 41 degrees. So our angle measure is still fine, right? 41 plus 49 plus 90 is 180. So we know we have the right answer. We know x is definitely -3. Number 10 is the same thing. So Triangle Sum Theorem tells us the measure of the three angles, interior angles of the triangle are going to add up to 180. So x plus 53 plus 80 plus 50 is going to equal 180. Okay. 50 plus 80 is 130. 130 plus 53 again is going to be 183 minus 183. X is going to be negative 3. And again, that's fine for our x value, as long as when we substitute it in to find the measure of our angle is going to still be positive. So here we would have negative 3 plus 53, which gives us 50 degrees, 50 and 50 and 80 gives us 180. So we know we're right there. Okay, number 11. Again, I know there's a lot of temptation just to say that these three pieces that they give us equal 180, but that's not going to be true. Okay, you have to look for what you do know and what you can't find out based on what we have already talked about. So we notice first we have a linear pair. So we know linear pairs add up to 180. So we know 180 minus 91 is 89. So the measure of this angle right here is going to be 89 degrees. Okay. Here we have two options. Okay, first option, and the easiest option, is to use our exterior angle theorem, which tells us that the exterior angle, so in this case 17x plus 3, is the exterior angle, is going to equal the remote two interior angles, so the opposite two interior angles added together. So 17x plus 3, the exterior angle, equals the opposite two interior angles added together. So 89, the measure of those angles added together. So 89 plus 50. So we have 17x plus 3 equals 139 minus 3. 17x is going to equal 136 divided by 17. X equals 34, 78, 8. Yeah, looks like it's going to be 8. The other way we could have done this is we could have found the missing angle here. So we know that these three angles of the triangle add up to 180. So 89 plus 50, if we call this y, plus y would equal 180. Okay, and then we would have 139 plus y is 180. Minus 139 for both sides, y would be 41. So we know this would be 41. Then we know these two would be a linear pair. So 17x plus 3 plus 41 would equal 180 degrees. And again, we would still get x equals 8 if we solve that equation. Okay, number 12, same thing. Again, we can do either way. Right, we can find the linear pair here and say this is 40, and then 40 plus 7x minus 4 plus 5x equals 40 plus 7x minus 4 plus 5x equals 180. Okay. But the easier way to do it is take our exterior angle. Okay. It's going to equal the sum of the opposite two interior angles added together. Okay, so 140 is going to equal 7x minus 4 plus 5x. So 140 is going to equal 12x minus 4. Add 40 to the other side. 144 is going to equal 12x. Divided by 12. 144 divided by 12 is 12. I'm always tempted to ask if there's any questions. Make a fool of myself. set. We have 13, 14, and 15. Okay. 13 is a pretty easy problem, but a lot of people struggle because it's not very explicit in what you're supposed to do. Okay. You want to find the measure of each angle. So if you don't know what to do right away, draw the picture. So we have a triangle. It's ABC. Okay, we have triangle ABC. It's telling us the measure of angle A is x. Measure of angle B is 1.5x plus 15. Measure of angle C is 3.5x minus 15. So here we have, they tell us an expression for each of the three angles of the triangle. We know by the Triangle Sum Theorem that the measure of the three angles of the triangle is going to add up to 180. So x plus 1.5x plus 15 plus 3.5x minus 15 is going to equal 180. Okay, we have x, 1.5x, and 3.5x. That's going to be 6x. And then we 15 and negative 15 are going to cancel, so we get 6x is 180 divided by 6. X is going to be 30. Okay, 14, we have an isosceles triangle. So since our isosceles triangle theorem says that if two sides of the triangle are congruent, then the opposite two angles are going to be congruent. So if this is x, we know this one is also going to be x, right? It's not going to be 42, it's going to be x. It's the sides that are opposite the congruent sides. Sides that are opposite the congruent sides. So we know that's going to be x because this one's x. So now we know x plus 42 is going to equal 180 by the Triangle Sum Theorem. The measures of the three angles of the triangle add up to 180. So 2x plus 42 is 180 minus 42. 2x is going to be equal to 138. Divide by 2, x is going to equal 1869. So here are our two isosceles. This is an isosceles triangle. So here are our two congruent sides. So these two angles are going to be congruent, which means this one is going to be 65. Okay, so we have x, 65, and 65. Right, don't make this x. It's the two sides opposite the congruent angles. Okay, so we have 65 plus x is 180. 65 and 65 is going to be 130 plus x is 180. Subtract 130. X is going to be 50. All right, for some reason, 16 and 17 were tripping some people up, but they're some of the fastest problems you can do here. So the isosceles triangle theorem told us that if we had two congruent sides in our triangle, we would know the opposite two angles are congruent. Okay. The converse to the isosceles triangle theorem tells us if our two angles are congruent, the opposite sides are going to be congruent as well. Therefore, we're going to have an isosceles triangle. So since these two angles are congruent, these two sides are the same. So x plus 1 is going to equal 12 minus 1 from both sides. X is going to equal 11. Here we have an equiangular triangle. And we know that if we have an equal angular triangle, we have an equilateral triangle. So if all the angles are the same, we know all the sides are going to be the same. So if these two sides are the same length, 2x plus 28 is going to equal 8 minus 28 from both sides. 2x is going to be negative 20 divided by 2. X is going to be negative 10. And again, that's fine as long as the length of the sides are positive. We can't have a negative length for our sides. So if we substitute it in, we would get 2 times negative 10 plus 28, okay, which is negative 20 plus 28, which is 8. Okay, so we know it had to be 8. So we know our answer is correct. So those two are the examples, or the first one was the example of the converse. The second one is an example of if we have an equiangular triangle, we know we also have an equilateral triangle. So those are two properties we should know. Okay, 18, 19, 20, and 21. These are kind of like what questions on your test are going to look like. You guys are not going to be given those simple diagrams. You're going to be given more complicated diagrams where you have to, or you need to use multiple steps in order to solve the problem. So 18, first thing we notice, isosceles triangle. So our opposite sides are congruent. So since this is 74, this is also going to be 74. Am I writing big enough? Yes. Okay, since that's 74, this is 74. If we were to call this y, okay, we would have 74 plus 74 plus y equals 180. 74 and 74 is going to give us 148. Plus y is 180. Minus 148 from both sides. Y is going to be 32. This is confusing to you, putting in the variable, and you want to think of it better as 180 minus 74 minus 74. That's fine. You're still going to get 32. Some people probably mentally, one way is better than the other, but not the same for everybody. So this is 32. Either way, that's 32. We also know we have a right angle. Right angles are 90 degrees, so these two angles added together are going to add up to 90. So 90 minus 32 is going to be 58. Okay, and then we notice we have an isosceles triangle here. So if this angle is 58, then this angle is also going to be 58. So x is going to equal 58. Number 19. Well, let's start with the other one. Okay, we have an isosceles triangle. So if this angle is 56, the measure of this angle is also going to be 56. And again, we can do 180 minus 56, or we can put in our own variable here to represent the measure of this angle. Then we can do 56 plus y is 180. This is 112 plus y is 180. Minus 112, y is going to be 68. So this is 68 degrees. We notice we have a vertical angle. Vertical angles are always congruent, so the measure of this angle is going to be 68. Okay. We have an isosceles triangle, so if that measure angle is 68, the measure of this angle is also going to be 68 because it is the opposite angle from the congruent sides. The opposite angles from the congruent sides. So now we have 68, 68, and x. So x plus 68 is going to equal 180. 68 is going to give us 136. X plus 136 is 180. Minus 136. X is going to be equal to 44 degrees. degrees. last two on this page. So 64. So these are vertical angles. So vertical angles are always congruent. So this is going to be 64. We have isosceles triangle. So the isosceles triangle theorem tells us the two angles opposite the congruent sides are also going to be congruent. So since these side lengths are the same, the angles are going to be the same. So this is going to be 64. We can do 180 minus 64 to find this angle. Just to be clear, I'm going to put in a y and then do 64 plus 64 plus y is 180. Okay, so we have 128 plus y is 180 minus 128. Y is going to be 52. So this is 52. These are vertical angles, so we know this is 52. And we have an isosceles triangle. So if this angle is 52, then this one is also going to be 52. 52 plus x by the triangle sum theorem is going to be 180. So 52 plus x is 180. So 104 plus x is 180 minus 104. On both sides, x is going to be 76. Okay, this one, again, we first noticed an isosceles triangle. So if this angle is 69, this angle is also going to be 69. Okay, so 180 minus 69 will tell us what this angle is. Again, just to be clear, I'm going to put in a y and do 69 plus y is 180. 69 plus 69 is going to give us 138 plus y is 180 minus 138. Y is going to be 42. So we know this angle is 42. And again, just like I think it was 19 or 18, we have a right angle. So this angle measure of these two added together is 90. So 90 minus 42 gives us 48. We have an isosceles triangle, so 48. Two opposite sides. Okay, opposite from the congruent sides, opposite from the two sides that have the same length. Then lastly, we know we have a linear pair. So 180 minus 48 is going to be 132. Okay, or we could say it as x plus 48 is 180 minus 48. X is 132. So 132. Okay, so these are the types of problems that are going to be on the test. Okay, you're not going to get the simple one triangle ones. It's going to be something like this, where you have to do multiple steps. Here we had to use the triangle sum theorem to find the third angle. We then had to use complementary angles because they add up to 90. So 90 minus 42 is 48. We had to use the isosceles triangle theorem again. Right, so we started with isosceles triangle theorem, then triangle sum theorem, then the definition of complementary angles, then the isosceles triangle theorem again, and then linear pairs. So this one had 5 different steps to it. Okay, that's the type of problem you're going to get on the test. Vertical angles, isosceles triangle theorem, triangle sum theorem, vertical angles, isosceles triangle theorem, triangle sum theorem. So again, six steps I think are there. All right, so those are the types of problems you're going to get on the test. You just got to follow your rules, look for what you can find out, and don't try to take it all in at once. Try to break it down piece by piece. So this is the 4th page. Okay, we want to write a statement of congruence. Right, so we're going to name the first triangle. So triangle, you can name it however you want. I just like going in the same order every time, DEC. Okay, you can name it DCE, you can name it CDE, CED, ECD, or EDC. So there's 6 possibilities for you to name. Any one of them will work. The key is when you make it congruent to the other triangle, you have to go in the same order. So I went in order D, E, C. So I picked D first. So there's two hash marks here. So that tells me that angle D is congruent to angle W. So I have to put W first. Okay, then I went to E. Angle E is congruent to angle X. So I have to put X second. Okay, and then I went to C. C is going to be congruent to angle C is going to be congruent to angle B. Okay, if you did just for example the measure of or you did triangle CDE, right? CDE, then you'd have to do VWX. If you did triangle EDC, then you would have to say that's congruent to triangle XWV. So you just have to make sure you go in the right order based on how many, right? This is telling us angle D is congruent to angle W. This is telling us angle C is congruent to angle V. And angle E is congruent to angle X. Okay, so you gotta make sure you go in the same order. Okay, the next one, I would just go in order. Triangle IKJ is congruent to triangle. So we're looking for what angle is congruent with angle I. Right, it's got one angle mark, so it's going to be R. Okay, we went from I to K, so 2 marks. So we're going to go to S. Okay, and then we went down to J. So we're going to go to the one with the 3 marks on it, which is 2. Again, we could have named the first one however we wanted, but once we name the first one, and again, we can whatever order you want. There's 6 possibilities. They're all going to be fine. They all work. Okay. Then when we say it's congruent to this triangle, we have to go in the same order. So same order that you put on the first one. So if you put J first, you're going to have to put T first. If you put K first, you're going to have to put S first. If you put I first, you're going to have to put R first. So you're going to have to go in the same order. Okay. We know which angles are congruent based on these lines that they give us. Okay. These are hash marks. I'm not really sure what you would call these, just angle markers. The angle markers that they give us. Okay. A few more. And we have 4 more. Okay. 24. So we want to name the 3 pairs of corresponding angles and 3 pairs of corresponding sides. So again, we're getting this from the names. Okay, so for naming sides, triangle RQS, they say RS. Okay, so that's the first 2 letters in the name. So the first 2 letters in the second name are CB. So we know RS is congruent to CB. The last 2 letters are S and Q. So we know SQ is congruent to BA. So SQ is congruent to BA. Okay, and then RQ is going to be congruent to CB. CA, RQ is going to be congruent to CA. We know the measure of angle R is going to be congruent to the measure of angle C, or no, angle R is congruent to angle C. Okay, the measure of angle R is going to be equal to the measure of angle C. So R and C are congruent. We know angle S is congruent to angle B. And we know angle Q is congruent to angle A. Okay, we could also name these using the 3 points, right? So angle R, we could have named angle QRS or angle SRQ. And angle C, we could have named angle BCA or angle ACB. It's simpler just to do it this way. Okay. Next one, they're not even giving us a picture. And again, we don't need a picture. You can certainly draw a picture. It would help to draw a picture. Okay. Let's do it first without the picture, and then we'll draw the picture in and make sure we did what we did right. Okay, so DB is going to be congruent to HI. BC is going to be congruent to IJ. Okay, and then DC is congruent to HJ. Okay, we're going in the same order. Angle D is going to be congruent to angle H. Angle B is going to be congruent to angle I. And then angle C is going to be congruent to angle J. Just go in order. DB is congruent to HI. BC is congruent to IJ. DC is congruent to HJ. Angle D is congruent to angle H. Angle B is congruent to angle I. And angle C is congruent to angle J. So for you to draw them in order. So D, B, C. Then draw the exact same triangle. Off the. No, we can still see. And name them H, I, J. And just know, since you drew them in the same order, all the angles and sides that you drew are going to be congruent in that same order. So then you can look at your diagram and go, okay, DB is congruent to HI. Right? BC is congruent to IJ. DC is congruent to HJ. Angle D is congruent to angle H. Angle B is congruent to angle I. And angle C is congruent to angle J. So you can do it without drawing the diagram, but if you need to draw the diagram and you think it helps, draw it. Same triangle, same order. So name it the same way. DBC, HIJ, and then you can look at them and see which ones match up. Okay. But you don't need to do the diagrams. We got two more, I believe. Two more good problems. I think these two are really good problems. So it tells us CBA is congruent to FGH. So if you don't see it right away, again, let's draw on what we know. So we know CB is congruent to FG. We know BA is congruent to GH. And we know CA is congruent to, CA is going to be congruent to FH. We know angle C is congruent to angle F. We know angle B is congruent to angle G. We know angle A is congruent to angle H. We see what we have that matches up. So we notice that we have CB is congruent to, what do we do around here? Hold up. So we said CB was congruent to FG. Okay, and then we said BA was congruent to GH. Okay. So sorry, that's what it's supposed to look like. CB is congruent to FG because it's the first two in each one. CB is congruent to FG. Then BA is congruent to GH. Then CA is congruent to FH. Okay, we notice with our two hash marks, we have an 11 and a 2x plus 3. So we know that AB is congruent to GH. Therefore, AB, right? So we know AB, or we'll call it BA, is congruent to GH. Okay, so BA, which means the length of B to A from point B to point A, is equal to the length of the distance from point G to point H. Okay, BA is 11, GH is 2x plus 3, minus 3, minus 3, 8 equals 2x, divided by 2, x equals 4. Okay, last problem, same thing. Okay, we can put in everything we know. So we know AB is congruent to AE, or AA, yeah. AB is congruent to AE. BC is congruent to EF. AC is congruent to AF. Okay, we know angle A is congruent to angle A. So again, that's not a good way to name the angle. We shouldn't name it angle A. It should be angle CAB is congruent to angle FAE. But regardless, we know that they're the same. Okay. Angle B is congruent to angle E. And then angle C is congruent to angle F. Okay, and we look for which ones we have in common. We see that angle F and angle C, we knew those were congruent, so angle C is congruent to angle F. The measure of angle C is equal to the measure of angle F. The measure of angle C is 3x. The measure of angle F is 87. Divided by 3, x is going to be 29. 90 divided by 3 is 30, so 87 divided by 3 is going to be 29. So that's the in-class review. So it obviously doesn't have everything you need to know, but it certainly has some of it. We're going to combine it with the other 2 reviews. You should be ready for the test doing all of those 3 reviews.